Okay, that all looks like it's working. Game audio looks like it's there. Microphone audio is there. Showing up on stream. Excellent. Okay. So the thing, I have seen like the first two sort of sets of these. So I know this means split it into two things of equal size and shape, and that they can be rotated or reflected. So that is the one thing I know going in. What pentameter do I want here? Or the other way around? No. Symmetric there. Does that help me? Well, these two need to be in the same pentameter. These two need to be in the same pentameter. Let's arbitrarily put this one in here. Well, I just don't see this one immediately. W. There we go. That. And then this means split into three shapes. I already even had a tutorial, I didn't even notice that. It was telling me. Go along here. Cut into three like that. Cut into three like that. Then there. That's the 6, and 9, 10, 11, 12. So these are still tetrominoes. T pieces, I see it. I see it. F, no, F, yeah, is it? Yeah. That's that one. Okay, so then this is the first one. This is where I stopped watching short playlist. So this is now new. This is, I think, means 2. Yeah, it means 2 and 2, and do they have to be different? I mean, other solutions to this would be like this, I guess. Like that works. That works. Whereas this won't. Okay. So here's a solution for that. Like that. So what could this be? This is now where I've got like lots of choices. So this could be 2 pentominoes and 2 1x1s. Or it could be 2 Tetris pieces and 2 dominoes. It's 2 Tetris pieces. What if one of the dominoes is down here? Well, that forces this to be... What does it know? No, it doesn't. It could be this and then split this into 2 Tetris pieces, but that's not going to work. So if this is a Tetris piece, then there's no way I can split that off, so I don't think that's there. What about 6? 1, 2, 3, 4, 5, 6. So I could have it in, yeah, I can have it in 3 and 3, yeah. Okay. Oof. Right. I want this to be 4, 4 and 3, 3, I think. That works. All right. So those need to be in different regions, I guess. Is it? Oh, but that was not saying these disagreed. Maybe this just, maybe the flashing red I can't trust yet. I don't know. It looks like they just need to be in separate spaces. Ah. How will this work? Because that... Oh, do they need to be in the same kind of positions? It's not just they need to be separated, it's that they need to be the same with respect to these. I see. So these aren't that need to be separated, it's that they're markers in the shape that need to overlap. Right? And I presume we can still rotate and reflect them as I need to. Right, so there's a reflection. Puts that on top of there. Right, but then how do I split these up? Because they need, if I'm, oh no, it's 2, 2. So these are 4 shapes like that. Oh, okay. Like that works. And no, not that. Or is it still 3? So this one I did 3, 3, 3, 3. I wonder if this is going to be like 4, 4, 2, 2 or 5, 5, 1, 1 or something. Hello, Najpa. Is that how am I saying that correctly? Welcome in. Um, who are you? Well, how did you find my stream? You have no idea who I am. I'm Dale Fishies. You can call me Fishies. I play puzzle games and puzzle adjacent games. I'm playing Insight, which seems like a neat, thinky puzzle game. I'm also playing some Coincidence. My favourite kind of incidents. Hello, thank you for the follow as well. Appreciate that a lot. Have you played Insight before? Or is it really just a random stream entry? Okay. So this is a puzzle game where basically you're kind of working out the rules as you go. I've just started essentially. The 2 means effectively I've got to split this into 2 shapes that are the same. So here's 2 shapes that are the same, whereas there's 2 shapes that aren't the same. You go. Okay, bye. Thanks for dropping in. Appreciate the follow. Okay. What was I doing with this? Oh, I'm thankfully looking away for a bit has helped me to see that immediately. So that's nice. Okay, so 2 shapes where these overlap. Well, if that wall's that wall in this. No. If this square were part of this, it would have to sort of go all the way around the outside. So this height has to be part of this. Makes me wonder if it's this here. No. That looks good, I think. Yeah, there we go. It's a reflection of each other. So that was me trying to sort of fill space at the top here, trying to work out how these 2 regions connect up here. And sort of going, well, if I go 4 up from here, and if this goes 4 up there, they overlap, so that's no good. Well, if this goes 3 up, I can go 3 up, well, that can work. And then sort of we're like, well, this corner needs to be here, and if I was to have that block and that block there, that kind of works, and then you just sort of split the rest of the shape up. So that was neat enough. Okay, lines. Well, it wants me to split it straight down the middle. I don't have any shape requirement. Does it just... It can't be in a 1x1? Is that what that means? Or is this... Huh. That does work, but this doesn't. Nor does that. Really, this is just saying this is wrong. Regardless. Okay. I don't understand this rule at all. Is it, oh, they need. This is just that it needs to be like a line-esque shape, and not a 1 by 1. A 1 by 1 doesn't count. Then it needs to essentially kind of be a line shape. So that doesn't work because this has a branch. That'll work. That'll work. That won't work because they're connected. Okay. Ah, and then this needs the branch. Okay, so this needs a branch of some sort. I see. Okay, well that can go there. There's your line, and there's your branch. So this is... How do you want to formalize this? It's all about connectivity of the squares inside, right? Because this has connected to 2, this connects to 2, this connects to 2, and then you have 1s at the end. And I wonder if it's... So I just do that there, and then I can put this basically anywhere, can't I? When I do that. Yeah. Okay. Oh, but I can only draw one line? Well, I guess I can only draw one line then. So this would be splitting into 2 lines, right? Which I'm guessing is the next one. No, it's not the next one. So I probably want, like, there. Not quite. There we go, that works. It's just the opposite. How about, so if I have this as a oh, I should talk about that creates. Okay, there. Yeah, that's a 4-way branch. Okay, so does this have to be like that? It does. So it doesn't have to be a 4-way junction. It can be 2 separate branches, but it does need to have 4 ends. Is that all I need to do to specify? I think it's just 4 ends. This counts the number of ends with only 1 other connected block. So I think how you'd want to count that is 1, 2, 3, 4. So now it's not even telling me whether I'm wrong. But I don't understand how I can even split this into 2. How can I split this into 2 shapes of equal shape if they're not? If the whole thing isn't equal. I mean, that works, but it's not telling me whether I'm right or not. Is this not right? What's wrong with this? So it's 13 out of 17, as if this isn't correct. Oh, it wants two shapes that are equal and then put this one in. I see, I see, I see. So two shapes that are equal plus whatever this one is. Okay. Okay. So three shapes that are equal. The 4 here is interesting. That's T piece. So I need another junction in there. Maybe it goes down first. No. Do I know anything about how this sort of tree structure has to, how much space the sort of tree structure has to take up that lets me know what size the other pieces have to be? Like if I have a tree in here, what's the maximum space it could take up? If it went like this, that's a tree structure, and it takes up a lot of space. And I can't then get 3 branches off it. I mean, I wonder if it's... Can I do something with this? – I do something with this? No, not quite. Well, let's just draw, you know, if I do, so I need to then break this up. If it was like this. Oh. Can a 1x1s break this up into tree? Like, how much tree-ness can a 1x1 impart? Not very much. Maybe if I do this and sort of work off of this. 2, 3, 4, 2, 3, 4. That's only a 3, 4 cube. I mean, this just seems. I don't know if they're going to get forking enough with. You need pieces that kind of. Oops. You need pieces that kind of have shape to them. So I'm noticing if I have to do dominoes, I kind of need to push in the corner, which makes me think it's going to be either 3s or 2s. 3s would want to be like this. And this, if I do something like this, I can't do anything with this. Can I? Well, that is the only thing I can do. But then I'm not going to be able to make this work out. Oh. I was told this game gets hard. It definitely does. Right, we can come back to that one. We can come back to that one. One where, so one shape and some square. That's two shapes. Oh, but that doesn't count it. The square has to be fully internal, I guess. Well, surrounded on four sides. There's fine. There's... No? Oh, because that divides it into two shapes. Whereas that doesn't count as a single square. Okay. So you need to avoid, you know, separating it into two. Fair enough. That means two of the one by one. Okay. Can they exist next to each other? They cannot. All right. Was it the case in previous puzzles that making it one by one did? No. So it's specifically when I have this square that it makes these little one by one regions. So now I need to place 3 of them. How about that? 2 regions plus needing to... Right, so this is the only place this can go, right? Yeah. So this has to go here, and then I need to split the rest of this into 2 identical shapes, which I can do like that. So now I have a choice of 3 spaces in here where I can put this. Since I can't put it over here, I know I'm going to need this sort of shape. Which makes me think it's kind of like this. Coming along here, I'm going to go 2 there, 1 there. No. So let me look at this again. I put that there. These 2 squares are the same in both, which means this isn't going to work. Let's just try doing this first. Unless it's well, it can't be like that. Yes, I can make them identical shapes like that, right? It's this one I want to get rid of because it's symmetrically opposite to this. So I'm just trying to make it rotational, right? But I can't do that because this can't be the one button. So if it were there, where could this sort of shape go? Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 blocks, which means this must be connected to 1, 2, 3, 4, 5, 6, 7, 8. So this would have to be this. And it's right because I've separated this off. And so this square needs to be in a region with 8 blocks total. 1, 2, 3, or 3, 4 into this one. 5, because I can't separate this off, 6. 1, 2, 3, 4, 5, 6, 7. So that's a 7 and 9. So it would be that or that, neither of which are the same shape. So it can't go there. Now we haven't separated this off in the same way. No. because that's going to make a 5 along here. I can't put that 5 up there. There it is. That was me forgetting, like realizing I can't do rotational symmetry because this block would need to map onto here. It won't work. I can't do reflection symmetry because this block will map onto here. It won't work. So it needs to be a 90-degree rotation type thing. And once I sort of grokked that, it was a lot more obvious where I had to go. These ones are just happening to see. I'm getting lucky. This one I'm also just happening to see. What is this? Still pentominoes? It is there. There. And then 5 of the same shape. Huh, 5 of the same shape. That's a weird one. So what are we talking about here? So we've got 6 by 6, which is 36, minus 35. So 7 is a heptomino. I don't think it can be like ever 6 wide, can it? Like if it's are these 4 outside shapes separate? This is a thing that the game could probably use, is being able to mark squares with colours. Just for noting things down. That would have been a nice thing for this game to have. Because I'm trying to use logic like, if I have this square, can't be the 1 by 1, so it must be in one of the heptominoes. Can these two be in the same heptomino? Well, if it were, it can't be, something like that, because that would then be a 1 by 1. So it can't sort of come out. It would have to come across here and out by 1 somewhere. So it'd be 6 plus 1 somewhere out here. Right, so either this L, this, or its reflections. And then how do I fit? Let's just focus on this. How would I fit another 5, another 4 even of those? Well, they can't now go vertically. They can't go horizontally here. So we have to have another one here. And yeah, that won't work. So I know these 4 outside corners have to be in different heptominoes. One, 2, 3, 4, 5, 6, 7. What does this look like? If I do this, oops. For this, something like that. 1, 2, 3. One, 2, 3, 4, 5, 6, 7. This one should have been like that. Yeah, that's not going to work. Just try other things I can make, rotationally symmetric. Well, that's not going to work. 1, 2, 3, 4, 5, 6, 7. Then that comes down there, which is going to block that off, so that's no good. That would, if this wants to hook in there, that's not going to work. Even if I make one of these, I then need to hook into here. And that isn't going to work. oops, when I look at that, is there a way that I can make this thing work? So we come up here. That pinwheel isn't going to be great, but I also can't really put that in there. This makes this a different shape. Can I move stuff in and out of here? Could I, for example, do that and have this come down like this? And then I need to put 2 more of those in there. If I have one in here, that splits that off into 2 regions, doesn't it? Okay. So rather than that, let's try moving a square up this way. Wait, I think that's 8. So let's try like that maybe. Well, that. No. Like that would be what I want. Yeah, there we go. Oh. Okay. This one unlocked before the other one, so this just want to be. I can't separate those ever at all. As soon as I separate them, they get angry. But it doesn't like that. Those need to be the ends of the shapes, maybe? Kind of looks like it, doesn't it? Yeah. Okay. So it does like that, but then obviously I need to put a better shape inside of there. We'll do that and that. Like that. That looks good. Can I split that up into 2 things of the same shape? Same size even? Same shape even, I do mean same shape. Be a hexamino. Where does this 2 go? Maybe not that. Does that mind being like that? Can I do? No, this actually does complain. So if I ever do that, it does complain. Can I get one? Can I test one with it slightly further apart? So if I do this, so it does have to be a line from one to the other. It's not just it has to be a. There has to be ends. So it has to be a line from one to the other. And let's just test, you know, I can't put that in with a, it does have to be a line, it can't have larger regions in there. And it can't be like that, or like that. I kind of want to do that. Let's put that up like that. It's definitely not like that, is it? Maybe it's just straight like that. Doesn't feel great, that particular split. This. Because if this comes down here, if this one comes down here, then there's two possibilities. There's that, or there's that. Alright, what about this? Can I do anything with this? I need a hook here. So maybe that hook goes there. Yeah, it's no good. So that goes there. No. It's going to be hard to do on stream because I kind of need to do symmetry kind of stuff, and I want to draw kind of two things at once. Yeah, I'm not feeling this as possible. Am I missing anything on this? Well, hang on. No, that's something wrong. Yeah. How did I get it to trigger a solution there? I wasn't paying attention. I don't know what it did, but it tried to take a solution. Before it even put, before it only drawn one line. If we come out here, I could even do something like that. That's clearly not going to work. Oh, let's have this as a possibility, but I didn't consider. Maybe I did consider. Because this hook looks nasty. Yeah, that doesn't look workable. Oh. This doesn't split, because this has to be split in half like that. It definitely can't be that. This is also the same problem. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it can't be that. If I do this, this overall one, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so 7. 1, 2, 3, 4, 5, 6, 7. Again, it would have to split up like that, so we can't do that. So this has to be either that, you know, if it goes there, it can't go out there ever, really, can it? So I think it's either this, this, or this. I know if it goes down, it has to either go straight to there or straight to there. And if it goes across, you go down, down. And if it goes out, I think you're screwed in any particular kind of case. You're always screwed. So I think it's this, and I'm just not seeing it, honestly. Hmm. 8, 16, so 8 octominoes. So we know we have a straight line of 3 because that has to come out to here. Okay, so here's some ideas. It can't be rotational or reflection symmetry directly, because that would produce an overall shape that is rotational, that it has the rotational reflection symmetry, and this shape clearly doesn't. So it can't be, you know, a 180 rotation. It can't just be a pure reflection. It has to involve a 90-degree rotation. So then where does this square end up in the other pentomino? Well, it needs to come down 3. If it's rotated at 90 degrees, then that, well, sorry, down 3, right 3. If it's rotated 90 degrees, that has to end up being an up 3 or a down 3. So where does that end up? Well, it's going to be like there or there, surely. It's there. Yeah, if it's coming up, where does this square go? Well, it's either, you know, off the grid, if you like. Same with this. If it comes down here, where's this square come? How does this square connect to this? Well, again, it'll be off the grid. So this square corresponds to either this square or this square. Well, these squares as well. It could, in principle, go down there. And again, you're sort of screwed with how you fit in these if you put this square here or here. So the outside one gets screwed. So I think this has to go either there or there. If it's there and it goes up, we are doing a 90-degree rotation like that. So where does this square go? It's going to have to be like that. There. And you don't hit there. So this square is impossible if I do that. I need like two. I need two cursors. Is what I need. So maybe I can rule out this. So if this comes down, this goes 1, 2, 3, 4, 5. It must have this L shape. This must be part of one of the octonions. Where can this L shape go? We can go there. This will come out to 6. And this would either have to go out here or here, which is impossible. So this L shape can't go there. Could it go there? Yes. Then where does this square come in? Well, it would have to come there and there. And then how do I fill in any of these? I can put one more in here. Like with this sticking out like that. But then yeah, that doesn't work. Phone vibrate. I keep coming back to this. So that's a 7. So it definitely can't come across here. Because however I add one into here, it doesn't match up. Right? So these two must be in different octominutes. Whoops. No, you haven't missed much. I am. This game needs a I need to be able to mark squares. Because otherwise it's really difficult to envision a lot of this stuff. I want to be able to go okay, so I know these are, if it's this, which I don't necessarily know, but if it's this, I know that there's 16 squares left, so they're octominoes. And I know these 3 have to be part of the same octomino. So I really want to be able to mark these 3 in the same colour, or something like that. To say okay, where do I build the other shape off from there? I know it has to be 3 in a line. Where does that 3 in a line go? Well, could it go there? Could it go there? It's kind of frustrating not being able to mark that stuff. I could go into Paint. You don't think this configuration is possible? Really? Does this look like the most likely? Because I can't go. What do like this? If I go down from here, if I think of the line I'm drawing from this, if I go down, it either has to do that or that, because the next square it picks up is next to this, right? So if instead it goes across, the next square it picks up is going to either go down and then it's next to this, so it has to be this, or it's a cross one. Well, if it's a cross one, you're kind of always screwed, because you're never going to make, you're now making this be a line. And so, for example, in this, the rest of the shape is what, 7 heptominos? 1, 2, 3, 4, 5, 6, 7. No, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So it would have to break like this just to keep the numbers equal. and it doesn't work. So I don't think this can ever kind of go like this, because you're just making lines with the rest of the shape that you have to break up in ways that don't work. So I think it either has to be this, this, or this. Of which, you know, if I look at this, now I have 1, 2, 3, 4, 5. These squares have to be in the same arctomino. And where does that go in here? Well, the 3 by 3, it's a V pentomino, with a V go there, 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 and that's it. And I don't see any of those working. Like that's definitely dead, because what the hell do you do up there? That doesn't work, because who collects this? Well, you could do this, and I mean, I'm still sort of working it through. Like, I don't see this ever working. Like, maybe it's this is there, and then this can never. Yeah, if it's up here, this pentomino. Tell you how big the two regions are. Okay. I mean, is it less than 8? Like, is it 8 or is it less than 8? It can't be more. It can't be more than 8. Less than 8. Huh. So that means it has to go out here, right? So can you make one of these work? I didn't think any of these would work. Because that's the only that's not going to work. Oh god. Okay. Yeah. Okay. I just didn't try that. I don't think. But when I was trying solutions that went around the edge, I think I just did that, and then went to like that immediately, and so I never tried that. That was a useful nudge, because that was just me discounting a possibility completely. Alright, so this is the same, but the dot's now up here. Okay. So can I do something similar? That doesn't work, because that gives me 2 different triominoes. That gives me 2 different tetrominoes. It gives me 2 different pentominoes. That I can't then. Well, let me try and be a little more systematic. So this is a static shape. Let's say this went down instead. Well, then that wouldn't produce a line. So this can't go down. Let's go across. Let's go back. Where can this go from here? Well, it's going to do across. Okay, so let's go back. This could then go up, or this is going to go left instead. If it went up, you wouldn't be able to draw lines, so it would have to come out like this, and we know that doesn't work. So we're here. If we went left instead, we wouldn't get a line here. Here again, go up. And now, if we went right, we'd separate off a 1 by 1, which we don't want to do. So let's go up again, and now we're next to this, so it has to be this shape, and that doesn't work because that chooses 2 different pentominoes. So we have to go back one. We were here, we will go back one further, we're in this square. Let's go up, and if we go up here, it has to be, it then has to touch the dot. Can this ever work? I don't think it can, no. Because this region, you know, I have to split it like there with 1 extra square. It's either that or that, neither which work. So now we are here, we can't go up. So we're going to have to go like here. Can this ever work? It doesn't look like it. 4. Yeah, that's not going to work, is it? Okay, so I think now we're on this, this, or this. Can I just see one of these? This is sort of the least branchy in this region. Don't see it. This kind of looks alright, like this region matches this. Yeah, okay. And then I need to make 3 regions out of the rest of this. So, do I have parity issues? I think I might. Because there might be odd even things that are interesting about this. So if I take out this, the rest of the square is 20, and you need to make it divisible by 3. But by lengthening, or rather an L, where? What does that in reference to? Okay. Okay, so back to this. So the region I leave out of this has to be elucidating the linear region as an L. In this one, you mean? Yeah. I don't know. I mean, maybe the solution isn't unique. I don't know if these all have unique solutions. Well, they certainly don't. I know some of these earlier ones don't. Maybe these ones do. Yeah, this one doesn't have a unique solution, so they're not all unique. Okay, so let's go back to logic out this. So this leaves a 20 square region, which doesn't divide into 3. So this is out. I wonder if it's going to be something like, you know, like leave something out like this, which is, you know, something like that, which seems difficult to reason about. If this doesn't, no, it can never be. If I go direct, like if I only take right and down steps to get from there to there, it will always take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of my 30 squares. So if I do something like, you know, like do something else, again, only taking right and down squares, it's going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's always going to leave 20 out. So I have to do some sort of more complex pattern. So if I, and here that adds in 2, which means my path now takes 12, and that leaves me with 18. And 18, let me check 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, that is a number I can split into 3. So I did that. 1, 2, 3, 4, 5. No, I want 6 in there. Oops. So moving that across isn't great. I certainly don't want it there. 1, 2, 3, 4, 5. Again, this doesn't work for the same reason. It's just a rotation of that. Let me go like this or something. Is this better? 1, 2, 3, 4, 6, 7. Hang on, what did I do? That's a region of 6 at least. Now I've actually successfully got a region of 6, but I can't draw this in here. Well, I could do something like this. Is this like that, right? Then the only space that fits in there is there. This only fits in there like that, or like that actually. No, I mean there are other ways that split the region up, but neither of which seem to work. So let me look at this again. If I do that and that, I want to have, yeah, 6. Well, so what else could I do? If I had more sort of wiggles in this, right, I'd add 2. I can only add to the path in steps of 2. And I need to add a multiple of 3 to the path, so I'd have to do, like, what's the longest path I can draw? It's like that or something, right? Maybe I'll make the more complicated way. We'll go in the middle. So that's a neat split into 2. But yeah. And there we go. That's a neat little solution to that. Okay. There is one I was stuck on, which was this one. Splitting this into 3 with a 4-way, or 3. Like this one took you a bit. Yeah, I was playing around with it. I just couldn't see it at all. How big the 3 regions are? Well, let me think about. Let me just get back up to where my logic was. Okay, so I don't think they can't be 1 by 1. That's just like where would they go? Like how would you make this into a tree structure with 1 by 1? So it can't be 1 by 1. Can it be dominoes? No, because I think you can't ever. And then I don't think you could ever get this as a tree with just dominoes on the outside. Right, so if I stop there, maybe. Yeah, because I need something at the top. Well, I need that. Yeah. I don't think you can ever get this into a tree structure with just dominoes. So it has to be 3 and up. Which is good because that's then taking quite a significant space of the whole thing. So if there were 3, we would want 9 of 11. So 9 split it into 9 with the 3 triominoes and then 11 with this tree. So can it be 3 by 1s? I don't think it can. I don't see how. this could ever make a tree. Oh. Okay. There we go. I just stumbled into that one. Is there something I should have... Is there something I can pick up on that? I just don't... Okay. What I'm learning, just from a puzzle design sort of perspective, is that these last tricky puzzles seem to have very simple actual results. Like here, the piece was a 4x1. Here, the piece was a 3x1. So I think one thing I'm learning is that from a puzzle design perspective, the designers likes final puzzles being neat. Last puzzles are either really hard puzzles or stupid trolls. Sure. But what I'm also learning is that they seem to like neat solutions with a kind of cute, you know, lots of straight bits in the final puzzles. We'll see how well that holds up. Right, so now we have that symbol, which I feel like isn't rendering properly. I feel like that grey bit is wider than that bit, but okay. What on earth does that mean? So hang on. So this is 2. So which bits are the 2? Let me. So what did I split that up? I split up. This is a 2, 2, 1, 1. Okay, so it looks like it's operating on crosses, right? And it's connecting those regions? Is that what I'm seeing? It's connecting this region with this, and then the other region will be this. So this symbol means anytime you have a four-way crossing, it's connecting the regions. I didn't mean to actually solve it. I was still playing around with it. But okay. Well, this seems like an absolute nightmare. Oh dear. This set looks worse than it is. It's pretty bad so far. You get all these weird diagonal bits sticking off of it. Okay. The regions stay small. Okay. That's good at least. So really you're now just splitting it up into regions with branches, like diagonal. I should just try and think of it as, like, just try and split it up into 2 regions, but the regions can connect diagonally. And go from there, I think. And like surely it's always going to have a diagonal in it somewhere. I mean, maybe not. Maybe they'll throw in one puzzle where you don't make a diagonal. But, No. What did I want? There. Yeah, that and that. 2 and 2. Okay. Because if I do that, it's not gonna. I can't. So you have to have diagonal connectivity. You can't not have it. Oh, right, that doesn't split it up. I was kind of thinking of these two, what was I thinking of? Maybe that didn't even work. No. Oh. Yeah, this is where I'm like trying to work out where there are diagonals is actually a real pain. Same sort of deal. Nope. Oh. Right. I thought I was just going to do it, like, I wonder how well you can use sort of checkerboard proof by colouring type things. 7 and 8 are one square different, yeah. A lot of those. But anyway, I was looking at like how well you could use sort of checkerboard proof by colouring type arguments. So in this case, sort of, if I colour this black and colour all checkerboard, colour in a checkerboard pattern where this is black and this is red and black. So we'll have there's 3 blacks and 5 reds. So we're not parity equal. Here we were parity equal. This is black, red. And so dominoes and diagonals. Dominoes have equal parity in one black, one red, and diagonals have the same parity in both. So here we had a black red, and a black and a red, which adds up correctly. Here, since we have other non-equal parity, we couldn't do the same shapes here because if we had two, you're always adding up an even number. Like a domino has an even number of black. If you sort of think of like it doesn't work for a reason that I can't quite put into words, but it's to do with the fact that the total number of shapes is even as well. So there's something that's like even times even must be even, but you need it to be odd, something. I think this has to be 3s and 1s. The shapes in 7 are all even sized. Yeah, I think this one has to be odd, like you're doing 1s and 3s or something like that. Like, Um, oh, did 8 without any diagonals. Okay, let me have a look at. Let me have a think of that. That puts diagonals in. Top row is a 1 by 1 and a 1 by 3. Oh yeah, that's neat. No, it's fine. I mean, I already got a solution. I'm not too worried about. I'm not too worried about spoilers. Like, I just kind of want to understand the mechanics, if that makes sense. Like, I'm not someone who really worries too much about like puzzle spoilers. As long as I'm sort of able to understand why solutions are what they are and how you're meant to sort of work things out. The mechanics are the real spoilers. They are, but it's not just the mechanics. It's how to think about the mechanics, right? Like what sort of logic you can use to sort of get a handle on them. And I think that's what's making me enjoy this more than understand. Is that understand it was really just about you find the mechanic and then that's it. You're sort of done, quote unquote. You just sort of the rest of it's busy work. Whereas the here, you've got to not just work out what the mechanic is, but also sort of have some idea of how you can logically get into that, work things out with that mechanic, and that's much more interesting to me. We'll see how well it sticks with that. But that's sort of my immediate thoughts of the game as a whole. It seems like more interesting to me, at least. Okay, so what am I doing with this? So 1, 2, 3, 7, 9, 12 into 4, so it could be 3s. 3 by 1s. Whoops. Like that. Okay. Ugh. So again, this is 12, isn't it? 1, 2, 3, 4, 8, 12. And this, you have to do diagonal stuff. Have to do diagonal stuff. You're probably going to do diagonal stuff in this, right? Right. Okay. All right. Still don't know quite if I've rocked that mechanic, but oh, it's okay. So these are split up now. So we want 3 of the same shape and then 1 which is different. So this I can't split into 2 triominoes. They do need to be. Do they need to be split into 2 triominoes? I think they do, because you need 4 shapes total. Oh, but you can split this into 2 dominoes, into 3 dominoes even. Yeah. Okay. So it's really a question of which one can you. It may not always be this question, but it might. It's currently looking like you're splitting one. You're working out which one can be split into 3 of the same shape. Um, so this has to be like this. It could go up, be a 4. That's going to be no good. It could be L. That's no good because it blocks off this. It could be a T. That doesn't work with this shape here. It could be L, which again breaks them off. So I think this one can't be split up. It must be this one. So this could be that. No. There we go. Okay. I mean, it looks so far like the less ugly shape is the one you're having to be splitting up. So that's where my sort of logic's going first. Not for this one. Okay. When I see it, indeed. That was a very helpful thing to just mention. Oh, I don't like this. What does this mean? What is that? Why is this a valid solution? Hard to formalize X. Ugh. How could that? All right. That's the same. That's not the same shape. Easier to intuit, but you've got to check her. Okay. Let's see if I can just get some solutions in that I can look at and compare. So I'm wondering if it's like something like if you trace around the outside, you can either have right-hand corners or left-hand corners, and there must be some way in which they're the same. So or something like that is what I'm starting with. Right, so here if I always go clockwise around. So we go, well, yeah, go clockwise, anti-clockwise, 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 clockwise, anti-clockwise, 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 clockwise, clockwise. So this is like the puzzle where you learn the rules are stricter than you like. Well, this is the same. I mean, if my logic holds up, this is what I thought the rule was. So, okay, so if I say it's like A, B, 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 A, B. There's another solution to 4 that should work, but doesn't, with my logic, you mean? B, 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 A, B, 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 A, B, 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 A, B, 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 B. B, 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 A. 1, 2, 3, 4. 1, 2, 3, 4. So that is the same. That doesn't. Ah. Mm-hmm. That doesn't. That doesn't. That does. So is it something like the lengths of sides between them? So I start here, go 1, 1, 2, 2, 2, 1, 2, 3, 1, 1. 1, 1, 2, no, 1, 1. No, it's not side lengths. I think, well, side length might mean it would be the same shape, wouldn't it? See, this I can kind of see as like, oh yeah, the same sort of outline, right? Yeah, hmm. Hello, Grace. How are you doing? I am struggling to understand this. So now I'm thinking of like, okay, like, is it like you take one shape and you can kind of expand it along one side in like one direction? So like, this one goes up here, right there, and then I can pull this one out here. Might be more than one side. Is it not only once? I think these will work at one side. So I put this one here and then pull this out by one, sort of extrude it a bit. Here I put this up here and extrude it here. Whereas if I did that, I would need to put this up here and extrude it in two sides. Here I can put that. Oh yeah, it isn't. And what's causing that to be? Thinking of shrinking instead of extending. Okay, that's a good point. I can think of it like that. Um, so I can take this and shrink this in here. So maybe it's all. So all sort of right-hand edges. If I take this thing and I can shrink it, and then I don't need to shrink this one because you know, without, you shrink it as long as there's space to shrink it into, and then I can shrink all right-hand edges of this into this. I can. No, that doesn't work for this. Because I would take this, I would have both of these edges and pull them in, and it would make an L. else did I have for this? Oh, this. No. I forgot what my other solutions were for this. Okay. Keep going. Okay. Maybe I will. What was my other solution to this? Because I can remember this one. Now I don't want to remember the other solution. This is my other solution. Okay. Okay, we can skip forward to the ones with the holes in. Skip 8, okay. Okay, 9 to end. Oh, and I also have a square, I see. I mean, this I can see why you would reject that out of hand, because it's just not really the same shape. This... Yeah, I do want to think about this some more. So what would I need to do? What am I doing to shrink this into this? So what is it? It is that. Oops. Square. That coming into here, or that coming into here. Either way, no. How am I even transforming this into this? Because this kind of has to grow and shrink. Because I need to make this bit bigger in one dimension. Like if I think of these, this is the distance to the edges. Okay, so they both shrink to the same shape. They both shrink to the same shape. So if I do that, that makes it's kind of A with the bottom chopped off. And I pull this in, it goes to A in the bottom chopped off. So I'm kind of just, they both shrink. This comes in here to there. This line comes in here to there. These also come into L. Yeah, it is easier to intuit than format lines. Yeah. And this also shrinks to an L. This shrinks to this shape. I mean, this is the thing it shrinks to, whereas this doesn't shrink at all. No, it comes in there. Okay. And this kind of looks like a four-way pointing inwards, so they're kind of all shrinking to the same thing. That kind of looks like a shrinking-ish symbol. So how do I make this? So if I did this, how does this shrink? It does, no, it goes to that. This one I'm just kind of, I'm just not seeing this one at all. Yeah, I'd be interested to hear how a formalization of this is logicked out. Is that not both? Do those not both shrink to an F pentomino? Maybe I don't understand it yet. Yeah, I see both of these as shrinking to an F pentomino. Like this comes in here and you get this. And then this comes in here and these two come down to make that. Is it because they're reflections of each other? They don't align to your expectations. Okay, maybe I don't understand quite how it's... Maybe I don't quite understand the shrinking then. Ugh. Shrink a shape, you can remove certain rows and columns. yeah, I don't see any way that the way I understand shrinking. Like, does this have to be? How do you make this into a like this? How do you make this into two shapes? With this being a line. Like this is, I don't even understand how you forget the shrinking. Like how do you even solve? Like how do you make this one shape that's still a line, like configuration? Because I have to draw from end to end. The line shape is not a shrunk version of the other one. I'm not talking about that. I'm talking about the two. The two applies to unclude regions. Oh, of course, right, yeah. That's one thing. That's what I'm forgetting. So like the way I'm understanding shrinking means that this would have to be like you'd need to have something like this to generate this coming down, across, this coming down, and then across. And that necessarily puts this inside the shape because that means it's 4 wide and no, that way around. This always ends up inside it because I can't, that just splits it into 2 horizontally. So yeah, I still don't think I understand the shrinking aspect of it. Not to worry about the lineage, just figure out where the shrink clone fits. Oh right, because I can rotate it. That's what I'm doing. That's what I'm forgetting. I can rotate the whole thing. So and reflect it. So no. Right. So is it when you have 2 rows that are adjacent or 2 columns that are adjacent and identical? And that is the condition by which you can remove one of them. And then you can just keep doing that until you stop. Yes? Was that a yes to the logic I just said? You remove this and get this. You can't remove any of them. This you can remove these and remove it again. And this you can remove one of these too. Okay, I got it. Excellent. Yeah, okay. I mean, that's not. It's hard to get to the formalization, but I understand. Yeah. So here you remove these two rows, or you reduce these two rows, and you reduce these two columns. Here you reduce these two rows, and that's it. Here you reduce these two rows, and that's it. So these two, now for the hard part, actually solving the puzzles. Well, I can't reduce this row, or this row, because these will never be identical to the ones below. 6 and 8 are the hardest. I will click on 7. So this, I'm trying to think, like, are there spaces that I know definitely can never be reduced? This one and this one can never be reduced. No, that's what I mean. If I do that, then I'm reducing it in the shape. So I shouldn't be careful because I'm splitting up the. I can split the row in two, so I can say, well, this and this are different, so they would never be reduced. But that's not true because I could do something like that, and then suddenly in this shape, I'm reducing these two rows, even though in the wider puzzle they're different. So. What was oh, hang on, so that then I need, the way I'm thinking of this bit, this sort of bit goes here, so I need up, right, but then I can't go back, can I? So it can't be like that. Oh, this is hard, you just happen to say it, fair enough. So as you just saw it, I'm just trying things and maybe I will happen to see it. No, okay, I'm gonna go in order just because this is smaller and therefore just has a smaller search space. Right, if this nub here is this nub here, then this going up and to the or this going left and down becomes this going up and right. So this needs to come up like that, and then I don't want any of this then. If that's the case, I don't want any of this to be in here because it's going to require going back out of here. So I want something like that. I want to do something like that. No, not quite. There it is. Okay, because these then shrink to Z pieces. Oh. Okay. Not quite. Right back. Cool. Oh, good luck with Lassie, thank you. because this then would need a lump at the top. If I don't put that in, then I don't get the bump here that I need. Aha! Yes, this goes there. Yeah, okay. So where does this shape end up? Here? I'm trying to work out where this S shape goes. When it goes down there. What if it goes down there? I need to have this come in somehow. Yeah, the shape can't be too complicated, but it's trying to work out where this unless I split it up, right? There we go, because it's. I was thinking of this as like this and trying to fit that in, but I can split it in half there. Oops. And come in there, and then sort of get a C shape. Okay. New mechanic. Okay. You happen to draw the light grey levels are one-off rules. Ah, I see. So this is a. Oh. Wait, which ones? These ones? Or these ones? Oh, these two, this 13 out of 13 and 10 out of 10. Those ones. They're very similar. These are very similar colours. But okay. That's good, because I don't want to deal with those ever again. Where was I doing? I was experimenting with this. So, mean, one is kind of a T and one is kind of a U. They kind of fit into each other. That doesn't. Hmm. Oh, so I can satisfy them separately. And these are happy with this. They're both happy with this. You can't draw a line that bounces off a corner. I mean, I was assuming that you can't. This is the region that's and like making this wrong, right? Like that just blanket fails. I mean, I'm assuming it's because of this region, no? This is what I was thinking, is that there's the 1x1 region that isn't, you know, there's no 1 up here that lets me have an empty region that's valid. Does this not satisfy either diamond? Oh, so that should be flashing. Okay. Well, this might be, well, okay, I'm taking that as this is what's wrong, but because this is what's wrong, it's finding that this is wrong first and not flashing. If that makes sense. Like, I mean, I don't know, you tell me, like, can you ever do this? Everything that's wrong should flash. Okay, so this is always just not allowed. Oh, it's directional. Okay, I should know. I should keep that in mind. You cannot bounce your line off a corner. Okay. So what's this rule is surprisingly simple. Yeah, it's like symmetry of some sort. Like, no. Is it just have symmetry? I guess those would symmetry about no. Not symmetry about where the symbol is. Why does that fail for this diamond? That's my question. It's a little more specific than just symmetry. Yeah, I mean, I've got that. Because otherwise that would have worked, right? This doesn't work. I mean, I'll just go. I mean, I'll just work with my assumptions and just whoops, see what, just play around with these first, I think. This needs to be that. Okay. So it specifically can't have four-way symmetry. It's only left-right symmetry or up-down symmetry and not four-way symmetry. Got it. Yeah, only that symmetry is interesting. It sort of makes it like it's a simple constraint, but it precludes sort of trivial solutions like just draw a box, you know, which is neat. That is neat. 13 is tough. I am finding that out. But if I have left-right symmetry, that does give me a logical sort of foothold, right? Because I know this square in this shape will have a counterpart somewhere to its right. If that counterpart is here, you always get vertical symmetry as well. Yes, you can't have a 2y shape that's horizontally symmetric without also being vertically symmetric. So let's put this here. So if this is mirrored here, well then these squares are going to be these. I think it's going to be wider, right? There it is. Okay. But that logic does, I think, will work by putting its reflection somewhere, because you've kind of got to match the border as well, right? Like everything about this square matches in its. So if I was to put this square here, you know it's got, you know, if these can't be part of this shape. Yeah. Remember that for later. I will, hopefully. Okay. This is interesting. Where does this one? So where are these? These were part of the line. You can sort of grow the line. But I'm not going to make a four-way symmetric shape. So maybe this, if this is part of the line, again, I'm not going to make a four-way symmetric shape, am I? So let's say these are part of this. Let me do something like that. Okay. This one, always good when you load up a puzzle and someone watching is like, oh, this one. Okay. This for a while. Okay. Oh, I still have a 2. So it likes that. Doesn't like that. It's okay with that. It's okay with that. It's not okay with a 1 by 1. Divides the 2 identical regions. Okay. Which I'm not really seeing yet. I'm just gonna keep going until I find one that fails, which presumably is this one. It is this one. So what's different about that compared to this? Is it just refusing reflections or something like that? Or only reflections? So this must be a reflection of all of the other shapes? Because these two are rotations of each other, and then this one has to be a reflection. So, if you were to do that, these are now all rotations of each other. Okay. But that's still what have we got? We've got a J, a J, and an L. Trem, hello! Welcome on in. I need to do it over here to do a share notes. How are you doing? How was the rest of your mob farm building? We are playing a puzzle game, as you... I mean, look at it. Maybe I'll just sort of introduce it with some of this stuff. So here, the sort of halfway done. Excellent. Presumably, like, halfway means that you've worked out how it's going together, right? Like, presumably it's halfway of a very repetitive thing. And once you've got halfway, you just need to finish the pattern, I would guess. Or is it not like that? Anyway, this is all Minecraft. I was lurking a little bit earlier. So here you can see I'm sort of splitting this into the same shape. And that is kind of, you know, what we're doing here. Importantly, these two are both kind of L shapes, but this one and this one are actually not just a rotation of each other; they're a reflection of each other. So that's allowed. I can both rotate and reflect regions onto each other. However, this is adding a new constraint, which is that it's sort of splitting it like these two are rotations of each other. This one with the bow tie symbol in it is also a rotation and a reflection. It has to be a reflection of the other ones, if that sort of makes sense. I don't know how well I worded that. So I just drew this, and you can see these two. Actually, what was the thing I did before? That was the thing I did before. So here, this one and these one are rotations of each other. I can rotate this 180 and make this. This one, however, will never rotate onto this. The correct solution instead was this. This will rotate onto this by 90 degrees, whereas these two will never rotate onto this. And so you're sort of splitting it up into shapes that can be, you know, one rotation. It's like one set of, it's really hard to word. Like, they're reflections of each other, which is what you want. But do that. These aren't reflections of each other. So you've got to make things reflections of each other. Like that. So this, if I have this sort of F shape, if I rotate it 180 degrees, it ends up as a there. And you need to reflect it to get it onto this. So since you need to reflect it, that's why this is correct. Hopefully that makes even a vague amount of sense. What am I splitting into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6. 6 and 6. Makes sense? Excellent. Okay, yeah, same sort of F shapes, right? Now this 2, 2 would normally mean, not this, nope. 2, 2 means 2 of one shape and 2 of a different shape. You know, you could also have like 2, 3 or something like that. I don't know how it's going to play around with these. So if we do that, these are now rotations of each other, so that's not going to work. If I want these to be non-reflections of each other, I'm going to have to make it at least 4 blocks. Because there are 2 shapes I can make with 3 blocks. This L piece or this straight line, both of which are symmetric. They have some axis of symmetry. And this one being the diagonal. And that means whenever you reflect it, it does nothing. It doesn't matter what axis I reflect it in. If I reflected it in this axis, it would go to this, but I could rotate that onto this. It is a property of any shape with any axis of symmetry. If you flip it over any other axis of symmetry, any other axis, you can always rotate it back into its original configuration. And so we're going to have to do a L shape. Is that it? Yes. There's the L, there's the other L, and these are the other 2. Nailed it. Thank you very much. Right, is this gonna? This could extend into here. Oh, I can do this. Yep. So that goes into there. That goes into there. Those are clearly reflection of each other horizontally. And then these 2 are the same. Now we have diamonds. It's suggesting this as an initial thing. So what does a diamond mean? Only this is working. I have no clue what this diamond is going to mean. So that doesn't work, but this does. Lolo, hello, welcome in. Yes, this game is weird. It is very much a pure puzzler. But I'm enjoying it a lot. Another thing it does that I didn't like about Understand is that when you have a symbol, once it means something, it just means that. The symbols don't change in meaning. Whereas in Understand, it was annoying having to sort of forget what a particular symbol meant from puzzle to puzzle. This, at least, they're consistent, which I like a lot. I found it a surprising mental tax to have to forget what symbols meant between solves. Yep. I do find it if you can time the second drawing right, you can get it to like not flash, which is annoying, but never mind. Okay, this I really still don't understand. Okay, so the diamonds are separate. So they're not dependent on each other, so they can be satisfied independently. This one's okay with a 2... No, it's not okay with a 2x1. Hang on. So I'm just trying to... I feel like if you time it right, the symbol doesn't flash even when it's wrong. Vaguely what shapes? Z's and... what is that? Is that Z to an S? I forget the name. I don't remember my pentameter names. They're all sort of Z's. I don't know the names of hexagonals for sure. Oh, it's rotational symmetry. It's 180 rotational symmetry. Okay. No, that's reflection symmetry. Like that. So these have some point about which, like this shape has a rotational symmetry order 2 around its center. So if I rotate it 180 degrees, I get back to the same thing. Same with this one, you rotate about this point, you get back to the same thing. Same with this about here, same with this about here. And that seems to be what the rule is. That at least seems to be working, so we'll go with that. There you go. That one can rotate about there. The question is it going to let me do, is it only 180 rotations, or, but they specifically don't have horizontal or vertical mirror symmetry? Oh yes, because I can't do this. Well, that means it's also not 4-way symmetry? Only order 2? No, because this has rotational symmetry order 2. So it can't have reflection symmetry. Okay. Well, I mean, if 4-way rotational symmetry maybe, I don't know. You'd need some sort of weird pinwheel sort of shape, right? Oh yeah, that one does work. Yeah, like here. So this does have four-way rotational symmetry. There we go. So four-way is fine. Almost like this game is well designed or something. So how would I want this to go? Oh yeah, because that's then a box which you can't have. There we go. Sneaky. This, how do I describe this? So this is a straight line. If you think of this as a line, like a connection of one boxes, this is a line with a little branch out from it. So if you think of this as sort of three lines spreading out from a point, if this was my point, here are like my three lines, 1, 2, 3. So that's what that means. And then this still means rotational symmetry. So where's this point going to rotate onto? So I kind of liked it here, right? No, I like it like this or something, is what I like. So something like this. In there, how about there be the branch? Okay, and you could also do like this if you wanted to go even further in. Okay, what is this? So is this 3 plus? Let's and then just, so that's 3 plus a diamond, yeah. Another troll puzzle, excellent. So how many do I have total? 6 by 5, that's 30. So this needs to, what does that mean? This needs to be a multiple of 3, the size of this, because the rest of it needs to be split into 3 equal sizes. So the bit that the shape, the bit of the shape that doesn't include the stuff that's in here, has to then be split into 3 equal sizes. There are three shapes of equal sizes, which means it must have a multiple of 3 squares in it. We have 30 total, 6 times 5, 30. And so if we removed, 0 squares, we'd be at 30, that's a multiple of 3, that's fine. If we remove 3 squares, we'd be at 27, that's a multiple of 3, it's fine. If we remove 6, it's fine. 9, it's fine. And so basically we want to remove a total of this rotationally symmetric region has to be a multiple of 3 big. So that's 6. I kind of don't like that. Because this is in a corner and can't be out like that. kind of think of a 180 rotational puzzle as kind of taking a square or a rectangle even and kind of cutting away at it, I think. You can kind of always think of it as that. Well, it has to be a rectangle with some amount cut away from it, because we know a rectangle is not allowed, because it can't have lines of symmetry. So what that means is you're going to get some sort of hook type. 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to get some sort of hook type shape, right? So something like this or something. No, because that's 9. Can't be like this. Yeah, what am I doing? I'm just sort of spitballing ideas at the moment. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so it's not this. No. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Ah. Nearly. The 3 regions were very small. Okay. Good to know. Okay. Yeah. Yeah, because that was me realizing, okay, let's say I map this onto here, then I'm cutting away at this rectangle. Well, I had to cut away symmetrically. So I was thinking, well, I can't put 2 shapes on one side and 1 on the other, because that won't be symmetrical. So if I, do something where I cut it on one side, you can do all sorts of things, as long as the shape's in the middle. How about this? This is a nice one. I kind of realised if you want, you could have two on one side and then one in the middle. In fact, I mean, actually, there's lots of things you could do. Yeah, anyway. Okay, so we've done those. So these questions are like, which one type things, I guess. So I need to split this into two and leave one left. Well, I can't split that into two equal parts, so it better well be this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 5, 6. 1, 2, 3, 4, 7. No, that's not true. That's not true. You can do that. You can do that. You can make these two the same shape and have the thing in there. Whoops, no. So now it's about basically finding where I can draw this in here while leaving the rest of the shape as one sort of contiguous block. Though I'm sure there will be something to break that at some point where I do divide this into two of the same shape. Because that sounds like something this game would want to do. That there. And I'm wondering if this is the one where... Oh. No! That is the one where I have to split one shape up into two equal parts. But it's not this shape. It's this one. Good little last puzzle there. Okay, this one was up earlier, so let's put this mechanic. What does this mean? 2 with building blocks. Ah! Okay, so I can build this shape out of these two. Oof. Right, because I can take this and put this one here and build this shape out of these two. But I can't split it into... I can't just split it all into one by ones. I can't make multiple cuts. Okay, I can cut that and rotate and reflect. So I can still rotate and reflect. And in fact, all of, well, not this. Well, this one is, yeah. So in fact, all the solutions are reversible, right? Because if I can build this shape, no, because I can build one shape out of these blocks, I could do the equivalent cut. Yeah. It's the same two pieces can make either shape. That's a good way of saying it. I mean, to be fair, I can just kind of work that one out. This only has so many cuts I can do, right? So it's that one. Same with this. I mean, there's only, well, now I've got to make 2 cuts along this, so that's, I can't really brute force that in the same way. this, yeah, this set's getting harder for sure. Interesting though, like a really neat. This is a neat idea. I think one way is to try and sort of visualize this shape sort of positioned over the other shape and sort of see where it fits. So this is one idea I had, where positioning this O over here produces something that kind of works. And then you can do the same. Then I realized actually if I put it over there, you can make the whole thing work a little better. So I think that's, like here, I'm immediately thinking like, well, you know, matching this edge to this edge. And if that were the case, well, you'd need to cut there to make the rest of the shape. So yeah, that's maybe, so here I'm sort of seeing, well, that kind of matches with that. Here, this kind of matches with this, right? No, hang on. There. Now this is tricky. Something like this? Yeah. I can't quite see that, but I can... Yeah, if you take this and fit it in there. Okay. I can't... oh, the stuff is written on place. That's why. And so this one is what? This? Put that over there. Over there. Don't overthink this one too bad. It's kind of happening. One there. It's not going to be there because that will go into there. This would be what? This would make. This. Well, no, I don't want to go above this line, do I? Because this would cut this off. So unless I do break up this circle, it's not like cut something out like this to move the hole internally, do I? So I do want to do something with the hole splitting open. I'm just really not seeing this one at all. So if I had this come off like this, just moving the hole. Where would I want? I want the hole here. No, I'd want the hole. Hang on. Yeah, so I mean, the way I was thinking of moving that like hold the right spot would be cut this out and move it down, right? But that doesn't work because I need to cut out a straight piece for this one. Or I. Okay. Okay, that's fine. What does that mean? Okay, but this also works. Okay. Is this just like an inverter? They need to be the same size, but not the same shape? Perhaps three pieces that are none of which are the same size? Or none of which are the same shape? Okay. Tetrominoes, absolutely. It's when it gets to like pentominoes that pentominoes I'm okay with. I forget the names of all of them, but when it gets to hex and beyond, I think most people are pretty stuck. Alright, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's still pentominoes. So I think we're going to have the one there, one there. Do I want a T piece at the top, or do I want a Z? Maybe a Z this way. A T there. Okay. Simple enough. Oh, I've got so many different puzzles to do now. Let's fit in this hole. Oh, good, colours. Okay, so this is why they couldn't. This is just like, hey, have you played The Witness? Because I've played The Witness. Do these all then need to be the same size? No? So red and blue regions can't touch, I guess. Well, sorry, regions of the same colour can't touch. So this has to be blue, this has to be blue. Okay, something like that. Okay, here we go. Now we get a bit of stuff like this. So This needs to end up separating all of these. And I assume I still need to have, like, you know, I can't just have empty regions, right? Like I can't just make an one-off random region. So one rotationally symmetric shape that separates all four of these. So let's build off of this. No, hang on. If this extends all the way across here, because that would then match this. And then oh, because then I need this thing in here. Does this matter if it's red? Yeah, so it can't be red unless I have this here. Unless it doesn't extend all the way, and this shape is something like this. Oops. So something like that, but then I need to make it non-symmetric. Okay. All right. So something with four-way reflection symmetry. Okay. That still wasn't too bad. At least for me. I don't know, this one. Right, so it's, what does this mean? I need to take off the same shape on both sides such that we're ending up with a line. Oh, of course, because I can't, no, it doesn't work like that. So I need to draw a line from here to here. No, because I can, what am I doing? If this goes into here, I always make two regions. So this must be part of the shape, right? There we go. So if this went up, the only thing I could do was this or this. And I can't draw that in here, can I? No. Or if I went there, I don't think I can draw this either. No. So I think this, if this went across, it would split it in half, so it's going to have to come down. Oof, I'm finding these ones difficult. That. Yeah, this. I mean, a lot of these sets are just neat but very tough. I'm not really seeing much way of getting through these other than just sort of staring at it until I see it, which isn't ideal, but it is what it is. I've not seen this yet, have I? No. So I will, unless that just means that, doesn't it? Okay. Yeah, that just means that. There it is. I think if this is going to be rotation symmetric, I'm going to need to pull this out. And was that true? No, because it could be like this or something. I like that as an idea, because I can rotate it like that. Why did I discount 2 1x1s? What do you mean? For that one? Because I can't. Because it's got verticals. It's not symmetry. Well, can you do that? Oh, right. Well, whatever. My solution was nicer. I like my solution. But I've forgotten what it was. No, it was like I liked this. No. Where was it? No, down here. There. I like that. So I'm going to have that. Is this just only go along the marked lines? Because if it is, it's not the most interesting of restrictions. No, why did I think that was going to work? Yeah, this one is like, oh dear, what do I? how do I want to... I mean, this can't be that bad, because you just... No. It's almost this. Makes the search space larger, how events will block together. Yeah. Yeah. I was just realizing that I was doing that, and I didn't need to do that. To have it in the middle. And yeah, I mean, I'm doing nothing with these other than just trying to see it. Like, oh, I can start on these. It's fine. Oh, excuse me. Oh, okay, 2 and 1. that it? No, that would need to be there. Okay. It took you a while as well. Not surprised. Sigma got it immediately. It's definitely one of these sets that you just got to see. I mean, I guess I can sort of think about they've got to add together to the same amount, right? So if I were to assume it includes this 5, then maybe it's 5 plus this would be 7. Then I'm looking for like 7 or 7 or 7. 7 there. So you're looking for two pieces of the same side. The set's entirely too long. It's all right. Too long P's. Okay. So these are together. Okay, well, let's start with thinking about that. Oh, I'm not seeing this at all. All of this. Oh, I see. Yeah, yeah. Yeah. Okay. Thank you. This one. This. No. I like the idea. It's just a bit. Yeah. It's not that interesting of a restriction, really. Like it's an idea, but I just don't think it leads to that particularly interesting puzzles, I guess. Um, mhm. Thank you. Um, Hello, Commsmite. Thank you so much for the lurk. Appreciate it. Ooh. Um, hmm. Okay. Yeah, these aren't particularly interesting. Like, I don't think I did anything particularly smart in spotting that. You just sort of stare at it and you see something vaguely sort of symmetrical. Yeah. Okay. Right, so what time is it? Quarter past. Let's go for a little bit more. Right, are these region sizes? And they also need to be shapes that are the same sort of thing. Right, so I know this is a 10. I added all of these up, so I'm going to need to split them. I want it to be, what, 8? These need to be 8. And what? So I want to. Um, no. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. Okay, yeah. That's where you cut it. Okay. Well, I'll continue on for a little bit. Oops. That doesn't seem too bad. I don't know. That was fine. Are you saying it gets harder this way? And so just stay doing down this way, or was it this particular set? Because that wasn't that. These are all just like Taichi puzzles, really. So split into 2 parts. The right side of the level. Okay, so you're saying stay down here rather than go up there, rather than that particularly being hard. Because I said that wasn't that difficult. Anyway, so this I'm making 2 bits that make a square. Possibly a rectangle, but we're starting with a square. There. there. No. It's 5. It's too wide. So the bottom is here, maybe. And I put that in there. Yeah. Mm-hmm. No. This is the top. And this will come in here. Um, we'll come back to this one. Yeah, maybe. This one is actually stupid hard. Oh great, this is the last two. Okay. Well, I know I need to cut this bit somewhere, this row and this row somewhere, because I know it can't be 5 across because it's a 4x4 square. So this top row has either been cut into 1 and 4, or 2 and 3, or 3 and 2, or 4 and 1. If I were to cut it here, then something like that. No, because then if I were to cut it here, this one would need to slot in there. This one is similar. I need to cut it along these two, definitely horizontally. Right, so do I know those 4 are one edge of the square? No, because I can do something like well, I also have to cut it. Hang on. Why did I say I have to cut it? These are 5, so I have to cut it across here. Right, so I have to separate this top line from this bottom line. Right, so I need a cut that goes from the left side to the right side to separate that top and bottom. I also need to separate this line from this line. So it's some sort of cut in the middle, no? Okay, yeah, I see that now. Alright. Let's do one more sort of this or that. How does this look? So this was make a square, and then this is a one is like a larger version of the other. What? So this one was all just this one was the one I was just making squares. This one Yeah, it's like, is it a square with like a hole in? What did I try this? I tried to do this. No, because yeah, so these are all, I'm guessing these are all going to make the same shape, but then I need to work out what shape it is. It may not be the same shape every time. Perfect. I mean, this fits in here, right? So it's the empty square there. This one, like, what is this even? Is there any other solution to this? There's this or this. Oh. Okay, so we've got at least 4 solutions. Including some non-symmetric ones. Yeah, what I'm wondering is if it's like you're making like a square and then a square with an empty square in it. Like you're making this, right? Like, why was it so easy to cut that 3L off the top left? And that was the solution to 2. Am I making the next one in the pattern? Right, because this can make 3, this can make 4. Can this make 5? Yes. So now I'm trying to make 6. If that's what this is, that's great. I like that a lot. So do I want to cut 5 to make 6? What? That's indeed what it is. What the hell is the last one then? Is the last one a square again? Or the last one number 1? I don't know. We'll get to that in the end. Where had we cut 5 to make 6? 6 is 1, 2, 4, 5 high. It's got this weird 3 by 3 thing. Oh, is it this? Yes, that goes on the end there. 6, then I need to cut to make 7. This set is also pretty hard. Yeah, but I feel motivated now that I've got it and I've worked out what it is and it's neat. You know? So this has got this number there. I'm trying to figure out which bit sticks into what. So if this were here. Because I can also consider it as how would I have cut 7 to make 6? I can at least see this. No, this I need to put. Oh no, hang on. This isn't as simple as I thought it was because it's a different size. Yeah, that's because that goes up there. Yeah. Anyway, back to this one. So it's 6. I definitely need to, if I'm cutting this one to make this, I definitely need to cut it vertically. This one in the set, yeah, I can see. I think it's going to be easier to envision it as cutting 7 to make 6. So let's think about that. I'll leave the solution. Because what forms this big 8x2 in 6? Could I form it by cutting here? And then having this be the top or the bottom or something? No. Is that it? No. Something like this, wouldn't it? But that's not it. Yeah, I feel close. Yeah, there it is. And you did this. It's this square to go up here. Yeah. 8. I need to pull what where. So, no, not quite. That, yeah, and then that goes. You sort of flip the pentameter around, and then 9. What do I make out of 9? Do I go back and make a square again? This is the bottom corner of a square, and then the rest of it is 1, 2, 3, 4. Wait, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So maybe I make this. So So maybe I'm making, what was that, 5x3? Which should be here. Okay. Okay, now we will leave it. Oh, so is the final thing like a 7x7 grid? Is that the final sort of set of puzzles? 7x7 is a 7x7. So I've done 21, 22, 23, 24, 25, 26 out of 49, which is oh no, because I can't count the ones I haven't done yet. 20, 21, 22 out of 49. But yeah, I think let's leave it there, because I can imagine the last ones are going to be harder. I imagine it's going to be harder as I get on, so there's no point doing half of it and then imagining that the rest of it is going to be another exactly equal sort of half. Okay, so I will, let's see, minimize window, minimize that, and let's have a look at who is doing what. So let's see. Oh, Michelle's starting Hades. Grace is streaming. Emma's streaming. Let's just do the easy thing and rate Michelle, because I want to see this. Yim doing Yimroids? I don't know Yimroids. I also don't know Celeste that well. I need to play Celeste myself before I start raiding into Celeste streams. But I don't know if I'm going to do that on stream. I don't know if that's going to be a stream. I do want to play it because I do like platforms. Like I played, a good chunk of like Super Meat Boy, and I enjoyed that. So the platforming bit of it sounds like it'd be fun. But yeah, I think I'm just going to do the easy raid and just raid Michelle. Okay, so tomorrow I'm going to get back on La Mulana Classic. Because I've also enjoying that, because that's been fun going through that. And I think I'm a lot more used to the controls than I was at the start of the La Mulana Classic stream. So yeah, we're going to finish that, because I think I just got, what did I just get? The bronze mirror? Yeah, I just got the bronze mirror, which is going to give me lots of options to do that. So that'll be fun. I'll get back on that 9 PM my time, tomorrow / technically later today here, whatever, blah, 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 blah. Anyway, see you all next time. I don't know when I'm going to stream Insight next. Maybe Sunday? Or maybe the week after? I don't know. But I'll work it all out. Who needs a schedule, really? Anyway, we're going to raid Michelle. Michelle's playing Hades. Hades is a game that I do want to check out, but I'm not really a roguelike guy. So I kind of want to check out via someone else playing it. So I'm excited for this playthrough. And yeah, I will see you next time. Bye-bye.